Hello everyone. We are going to continue our discussion with stack abstract data type, how we can implement a stack abstract data type. So just a reminder, in last class we talked about what is a stack and the operations we are going to implement in a stack. So as we know, every abstract data type means their collection of attributes and functions means operation. Okay, now a stack data type means it's a list that actually operates in a specific fashion, which is known as last in first out fashion, or also known as LIFO fashion. So the operations we are going to implement in the stack, they are known as push, pop, pick, and is empty. Okay, all right. So just remember that all of the operation we expect to implement all of the operation to run in order of one time. Okay, in constant runtime. All right. So we are going to implement push, pop, pick, and is empty operation, and preferably we want to implement them in order of one time. Okay, and in last class we saw how we can implement all of those operations using a dynamic array. All right, so in the dynamic array, I'm going to now jump back to my discussion with the dynamic array. All right, now in this dynamic array implementation, so as this is a array and array needs a array, all the arrays are of fixed size. So in that case, when we are going to push one item in the array, if there is no enough room left in the array, we may have to call the resize function to resize the array. Okay, and that's how this function looks like. So because of this resize function, because here, so in the push function we may have to resize the array if there is no room left in the array to insert a new item. Okay, and because of this resize function, the runtime of push function in the using the array is going to need order of n time. All right, and this resize function is going to actually take the order of n runtime. All right, because in this resize function we are going to create a new array. Let's see, this is our old array. All right, and we are going to create a new array. Okay, so in this implementation we are going to create a new array exactly with the size of double as the old array. Okay, and we are going to copy all the values from the old array to the new array. Okay, and that's our new array, and then we are going to start adding the items in the end of the array. All right, so because of this resize function, our push function is going to take the runtime of the push function is going to be order of n runtime. All right, but pop is the runtime of pop is expected order of 1, and peak is also order of 1. But the problem is only with the push function, as we discussed that all of the operation push, pop, peak, all of the operation we expect them to run at order of 1 time. Okay, all of the operation we want to run them in order of 1 time, but the push function is going to take order of n runtime. Okay, and is empty function, our first example was is empty function. That's also a very simple, just by looking at the variable value of top of stack we can actually say that this our stack is empty or not. Okay, so we can add here the new function is empty also runs at order of 1 time using our array based implementation. Okay, all right, So that's what we saw. We can implement the stack using dynamic array. All of the operation is going to run at constant runtime. Only the push function is going to need, in worst case it is going to need order of n runtime. Alright, now let's see, can we implement a stack using linked list? Okay, so that's an example of linked list, and that's an example of singly linked list. Okay, I'm sure you can remember. So we are going to need a head pointer. Head pointer will point to the head node. All right, so that's our head node, and our first value is 40, 30, 20, 10, and this is our last item in the linked list, and last item will point to the null pointer. All right, now the question is that if we want to implement a stack using linked list, we know that the um, uh, push and pop, I mean inserting and deleting node, follows the last in first out fashion. Okay, so first question is that how we are going to implement a stack using linked list. So if we implement a stack using linked list, in which position we are going to add the node? Okay, so having a existing list, or I mean say having a empty stack. Okay, so what is going to be our pattern to insert a new node? All right, okay, so here what happens, let's see, we have a completely empty list. Okay, means empty stack. So this is our head node. All right, and this is our actually the head node. Okay, head node is pointed by the head pointer, and this is pointing to null, so that means it's a empty stack. Okay, now a new value comes up where we are going to insert the node, at the end of the list or at the beginning of the list. Okay, so that's the major decision we have to take. Just remember that all of the operation insert, so all of the operation push, pop and pick, all of the operation we are going to, and also is empty, we want them to run in order of one time. Okay, so that's preferable. So if a new node comes in an empty stack, where we are going to insert the new node, at the front of the list or at the end of the list? So what happens if we insert a new node at the end of the list? Okay, so if we insert a new node at the end of the list, means now you can just go back to our linked list implementation, linked list abstract data type. Okay, so inserting a new node in the end of the list means what is going to be our runtime. Okay, so inserting a new node at the end of the list, okay, if our push operation works like inserting a new node at the end of the list, what will be our runtime? Okay, so in that case our runtime will be order of n, right? So if the stack has n node already, and we are inserting and our push operation is working like inserting a node, the new node at the end of the list, means it is going to take our runtime is going to be order of n, right? So that means push operation will take order of n runtime if we insert a new node at the end of the list. Okay, also if we insert a new node at the end of the list, means last node is going to be our top of stack, right? So this is the node we inserted at last, so it will be our top of stack. So if pop operation, how the pop operation should work, means we have to delete the last node, right? That means actually for deletion also, for pop operation also, we have to go back to the last of our linked list and we have to delete the last node. Okay, all right. So it means pop function is going to also take order of n runtime, which is worse than our array based implementation, right? And that's also not something we are looking for. So preferably we want to implement our push operation, pop operation in order of one runtime. Okay, so that is the idea. In a singly linked list based implementation, if with insertion and deletion done at the end of the list is going to be most time consuming. All right, because we have to traverse the entire list for every push pop and also peak operation. So peak operation means we want to read the last node, right, the top of the stack node. So that means we have to for each of the operation, push pop peak, all of the operation, we have to traverse the entire list, and they are going to take order of n runtime. Okay, so now what is the solution? The solution is that instead of inserting at the end of the list, we are going to insert at the beginning of the list, at the front of the list. Okay, now how it will look like, say we have a empty stack. Okay, so a empty stack will look like this. All right, so we are going to have just a empty pointer, we're going to have a head pointer. Head pointer will point to a node, so which is actually the head node. Okay, and head node will point to the null, and that is that that will look like our empty stack. Now when we will add our first value, push value, the first value we are going to add it at 0 position. 0 position means after the head node. Okay, so head pointer is pointing to just a head node, and after the head node we are going to add our first value. Okay, so this means this stack has just one value. So just remember how we implemented linked list, right? So here the first value we are going to add them after the head node. Okay, and we said that in linked list implementation also this is going to be our first value. So the position here we are considering them at position 0. Sorry, I should tell that at index 0. Okay, now if I get another value, push 20. Okay, now these 20 we are going to insert them at index 0. Okay, so index 0 means at the beginning of the list. Okay, so beginning of the list means after the head node. Okay, so after the head node, so that's our head node pointed by the head pointer. Okay, so after the head node, all right, we are going to insert the new value. All right, so 20 will be 0, 20, 10. All right, so then another value comes of 30. Okay, so that's also we are going to insert them at index 0. So another value comes of 40, we are going to also insert them at index 0. Okay, so 40, 30, 20, 10. All right, so let me ask you now, what is the runtime of this implementation? So push function is equivalent to, push function means inserting a node at index 0. Okay, and we already actually saw the implementation in the linked list. Now here in the linked list we implemented the function like that. We implemented the function, given a position, given a 0, this is going to insert a new node in the linked list. Okay, but here the position is always fixed. Here the position, the index value will be always fixed. Okay, just after the head node. Alright, so the position will be always here after the head node. So here means, that means you don't have to traverse the entire linked list. Okay, the position is fixed, so it means you know this node pointed by the head pointer, and after the head node you are going to insert your new node. Okay, all right, so what is the runtime? The runtime is order of 1. Okay, means it's a constant runtime. It doesn't matter how many nodes in this stack has. Okay, so the stack could have 1000 value. You are always inserting the node at the fixed position and after the head node. You don't have to traverse, you have to just come to this position at the head node, the first node, and then you are going to insert this new node. Okay, so it doesn't matter how many node in your stack is, so your algorithm doesn't depend on the size of the input. Okay, your algorithm doesn't depend on the size of the stack, so the runtime is going to be always constant. Okay, all right, so that's how we are going to implement push function in the stack. Means we are going to insert a new node at index 0, and that's how our runtime of push function will be order of 1. So let's see the function. Okay, so push function means now we are implementing the stack using singly linked list based implementation, and that's why we are not showing you the data structure of node and the list. Okay, so we are using the same node class definition as we used in the singly linked list. Okay, same node class definition and same list class definition. So we are using same node class definition and same list class definition. Here I mean, instead of list we are going to call them a stack. Okay, so the class definition will be same, just instead of giving the class definition list, we are going to call the class a stack. Okay, but the stack is now the stack will have the same class definition as a list class. Just the only difference is the function name, the operation name. As we said, each stack will have this couple of operation, and the definition is going to be different because in this, in push, pop, pick and is empty, they always follow a specific order. Okay, all right, so now let's implement the push function. Okay, and push function is same as insert an element at index 0. All right, so how this function is working, we are going to have a two temporary pointer. All right, so two temporary pointer, current and previous. Okay, now we are going to create a new node based on the parameter data. So the push function takes a parameter, say push 40. Okay, now you have a stack, you are going to add the new value 40 at the top of the stack. Okay, now let's see how this function is working, and from here you can see that this is not actually, there is no loop inside here, so this is not actually traversing the entire list. Okay, just it's a fixed position. We're going to always insert the node at the position 0. So let's see a given a stack looks like this. It doesn't matter how many value are there in the stack. Okay, and we have the head pointer pointing to the head node. Okay, so this is our this is actually our head node, and this is our first node in the existing stack. Okay, All right, let's see, this is 30, 20, 10 and rest of the value. Let's say we are going to insert 40. Okay, so how this function is working, so we are going to have two temporary pointer. So the first pointer is going to be the current. It is going to point the get next of head pointer. So head pointer is pointing to this node, so get next will be the value, the node with the value 30. Okay, so this will be my current, and previous is going to point to the same pointer that head pointer is pointing. Okay, so this is will be my previous. All right, so that's our line 1 and 2. Now here I am creating a new node, okay, with the value data, and the next point the next pointer is going to point to the current node. Okay, so just let me remind you, each node has two attribute, data, and the next name is next, which is a node type pointer next. Okay, so I'm going to create a new node where the value will be, the data will be this data, same data, so the data will be 40. Okay, and the next pointer is going to point to the node current, so it means this is going to point to the node current. Okay, let me use a different pen color. Or let me use blue. It is going to point to the current node 30. Okay, so that's how I created my new node. So now let's look at the last line. So now previous is so I'm calling the function of set next pointer for previous node, this one. So the next pointer of previous node is going to be the new node. So instead of this one, now previous has the next pointer, which is the current node. Now instead of that, the next pointer of previous will be the new node, so it will point to the new node. Okay, so that's how my top of stack will be the value 40 and 40, 30, 10, 40, 30, 20, 10 and rest of the value in the stack. Okay, so anytime I have a new value, it will be always inserted at the top of, at the index 0. Okay, all right, so okay, so in the next segment I am going to talk about the pop function.